Welcome to our video tutorial on dark web scraping with Python. In this video, we'll be discussing a Python script that uses various libraries and techniques to extract data from onion websites. We'll cover the code structure, functions, and dependencies. Let's dive right in. Before we start, let's understand the purpose of this Python script. The goal is to crawl websites, search for specific data based on a keyword, and generate an HTML report with the results. This can be useful for various applications such as data mining, research, or finding specific information on the web. Now, let's take a closer look at the code and understand its structure and key functions. The main function is the entry point of our script. It handles the overall workflow and coordinates the execution of other functions. It reads initial URLs from a file, crawls the sites to find new links by using a link_finder function, and calls the search_requested_data function to search for data on each link to search the provided keyword. So, the link_finder function is responsible for crawling websites and finding new links to explore. Let's dive into its detailed explanation. The link_finder function does the following. It takes user input to determine the maximum number of sites to crawl max_sites. It initializes a set called crawled_sites to keep track of the sites that have been crawled. It reads initial URLs from a file called URL. It loops through each URL and sends a request to retrieve the HTML content of the site, and adds the current site to the set of crawled sites. If the request is successful, it uses regular expressions to extract links from the HTML content. It writes the discovered links to an output. It processes the newly discovered sites recursively by adding them to the URLs list. Now the search_requested_data. The search_requested_data function is responsible for searching the requested data on a given website using a keyword. The search_requested_data function takes three parameters: link, the website link to search, keyword, the keyword to search for, and result_file, the name of the output file to store the results. Here's how it works. The function starts by creating a new instance of the Firefox driver using Selenium with proxy settings for Tor. This allows us to automate the browsing of web pages using Tor network. The function then loads the main link using the Firefox driver and waits for the page to fully load, including any dynamic content. Once the page is loaded, we get the page source, which includes the HTML content of the web page. We create a beautiful soup object from the page source, using the HTML parser. This allows us to easily navigate and extract data from the HTML structure. We create a new HTML structure for the report if it doesn't exist, or load the existing structure from the output_file. Now, we can search for the requested data by looking for the provided keyword within the HTML content. We use the find_all method of the beautiful soup object and provide a regular expression pattern to find matching elements. For each matching element, we extract the relevant data and store it in the HTML report. We extract the title of the web page as the site name and add it to the HTML report. Finally, we write the HTML structure, including the requested data, site name, and URL, to the results HTML file. To run this script successfully, we need to install and configure a few dependencies. Let's discuss them. Make sure you have Python installed on your system. You can download and install Python from the official Python website. We use the requests library to send HTTP requests to websites and retrieve their HTML content. You can install it using the command pip install requests. The beautiful soup library helps us parse and navigate the HTML structure of web pages. It simplifies the extraction of relevant data. Install it with pip install buttifulsoup4. In some cases, Websites use JavaScript to load content dynamically. To handle such situations, we employ the Selenium library, which automates web browser actions. Install it with pip install Selenium. Since we are using Selenium with Firefox, you'll need to have the Firefox web browser installed on your system. Additionally, download the appropriate Gecko driver with respect to your Firefox version, which acts as a bridge between Firefox and Selenium. Firstly, we have to configure the path to the Gecko driver executable in the environment path. Move the downloaded Gecko driver binary to the /assr/local/bin/ and make it executable. Then open the ~bashrc file using a text editor. After that, scroll to the end of the file and add the following line. Export path equals /assr/local/bin $path. Then apply the changes to the current terminal session by running the following command. Source ~bashrc. Now to verify that Gecko driver is added to the environment path, use the command gecko driver version. With the dependencies installed, let's execute the code and see the results. In the command prompt or terminal, navigate to the directory containing the Python script. Execute the command Python script _name, py, replacing script _name, py with the actual name of the script file. As the script runs, it will ask you the maximum number of links to be crawled through the initially specified websites and displays which area being crawled. Then displays the number of total links found and asks on how many of them do you want to crawl for the keyword. Then type the keyword you want to search. It will load every link on Firefox and is searching for the requested data based on the provided keyword. After specified number of links are crawled, the results will be saved in an HTML file named results.html, and they will be shown automatically. That concludes our detailed explanation of our project Dark Web Scraping with Python. We've covered the code structure, functions, and dependencies. You should now be able to run the script and extract data from websites efficiently. Thank you for watching. We hope you found this tutorial helpful in understanding dark web scraping with Python.